Story continued from Torvosaurus episode. The late Jurassic of North America is home to some of the time period's most incredible species to walk the earth. The dry season has just begun, but much of the vegetation has stayed lush. However, some smaller creeks and rivers are becoming dry, and this forces different species of dinosaur together. Down by a still-flowing river, a herd of Camptosaurus file up to the slow-flowing water. Amongst them are the smaller Dryosaurus, happily mingling with their neighbours. Further down from them on the same bank is a duo of Stegosauruses, their impressive backplates parting the sun's rays as they feed on the low-lying plants. With so much prey, there are predators. 4 Hesperornitholestes are close to the large herd, but at under a metre in length, they are no threat to any of the herbivores here, which can't be said about the Ceratosaurus further up the river, on the opposite bank. The scarred female is here to hunt, but not on any of the herbivores who are keeping a cautious eye on her. With the water in the river dropping, the female has come here to look for any large fish like lungfish that are more exposed than they were in the wet season. She carefully patrols the riverbank, but regularly checks on the largest herbivores at this part of the river. Crashing through the forest behind the Camptosaurus and Dryosaurus come a herd of huge sauropods, Apatosaurus. This herd contains over 30 members, the adults averaging 23 meters long, with some of their older members being close to 30 meters. These giant herbivores are slowly making their way through the forest on their annual migration, eating anything they can reach. Though they are mostly mid-level browsers, they are 4.5 meters tall at the hip, and their long necks can reach even higher if they have to. Using the peg-like teeth at the front of their jaws, they effortlessly nip and strip the leaves of ferns, branches, and trees, and then swallow them whole. Taking the time to chew would mean they spend less time putting food in their mouths, so these sauropods, like many of their close relatives, pass solid food directly into their stomach, and let it do the food processing. To aid their massive gut, the Apatosaurus have swallowed stones that help to grind down all that plant matter, speeding up the process. Sometimes the leaves they want are a little out of reach, and so on the occasional tree, the Apatosaurus do something that for them is quite athletic. One male lines his shoulder up to a suitable tree, and then rears up on his hind legs, sending his head and neck almost vertical. He then rests his right foot on the tree he wants to bring down, and patiently waits. With over 20 tons of sauropod leaning on the tree, it is only a matter of time before it bends, cracks, and then falls to the ground. The sound of crashing timber startles the flock of herbivores by the river, causing many to jump or swing their heads to the source of the sound. The stegosaurs, however, don't react. They are used to being within close proximity of large sauropods. Some of the Apatosaurus swing their long necks to the top of the toppled tree and start to feed on the leaves that were previously out of reach. It is because of these huge herbivores and many others like them that forested areas don't become overgrown or too congested. As each herbivore moves through the forest, they clear overgrown plants or trim down others, and their clearing of trees, or just their movement through the forest, keeps low-lying areas more open. What is most incredible is that the plants they feed on are able to recover and regrow at such a rate that multiple species of sauropod will walk through this forest, and all of them will be able to feed. A carefully balanced ecosystem that has taken millions of years to accomplish, and is one of the reasons sauropods grew to such massive sizes. The mixed group of herbivores have all drunken their fill and moved back into the forest to feed, away from the approaching Ceratosaurus. The scarred female looks over the slow-moving Apatosaurus. She was nowhere near a threat to them. She could take one that was closer to her size, but there were no individuals in this herd. They were so far out of her league, she could likely walk amongst them, and they wouldn't be bothered. In fact, she had done so in the past. They were far more of a threat to her than she was to them, and so she stayed on her side of the river, and continued to look for a meal. The dry season was beginning to bite, and she had to do well, before water and food became a rarity. Hello everyone and welcome back. Today we will be breaking down one of the largest Morrison Formation sauropods, Apatosaurus. Apatosaurus's first remains were discovered in 1877 by a miner in Colorado and was named Apatosaurus ajax by Charles Marsh. A second species was discovered in 1916 by William Holland and named Apatosaurus luesii. A study of sauropods done in 2015 also put a third species in the Apatosaurus genus, resurrecting Brontosaurus as a junior synonym of Apatosaurus. Brontosaurus and Apatosaurus are historically intertwined, but I will cover that history in Brontosaurus's own episode. So for now, let's get back to the breakdown. Apatosaurus was a genus of sauropod in the Diplodocidae family, and lived between 152 and 150 million years ago in the late Cretaceous of North America. It had a typical sauropod build, with a long horizontally held neck, small head, bulky body held up by 4 pillar-like legs, and a very long tail with a thin whip-like end. Many individuals have been found, but as with most large sauropods, these remains have been fragmentary, making calculating the species' size difficult, with some individuals being far larger than the average specimen. On average, Apatosaurus is estimated to have grown to 23 meters long and stood 4.5 meters tall at the hip, with large individuals growing close to 30 meters long. Weight has been far more variable over the decades, with average estimates putting it between 22 and 36 tons, with high estimates being close to 42 tons. Such is the difficulties of calculating the weight of an animal with only a few bones to go off. The skull of Apatosaurus was not found until 1970, which actually led to scientists reconstructing models of it with a Camarasaurus skull. The actual skull was more similar to its close relative, Diplodocus. Despite being similar in size to a humpback whale, Apatosaurus's skull is around the same size as a horse's, and is also quite square-shaped, with only Nigersaurus having a square skull. It had chisel-like teeth with a thick enamel surface, which would have been used to strip plants of their leaves, and then swallow them whole, since they didn't have chewing teeth. Of course, with such a small head comes an even smaller brain, which somehow operated the enormous body of this huge animal. It should be no surprise that Apatosaurus and other sauropods weren't very bright. The long neck was not particularly flexible, but it would have been able to move its head in a wide horizontal arc, allowing it to feed across a wide area without moving its body. Though it may have been able to pull its head and neck up into a more vertical position when, say, alerted, the resting position of its neck would have been more close to the ground. This, along with the square head, supports the idea that Apatosaurus was a low to mid-level browser, feeding on ferns, cycads, and horsetails. The neck vertebra also have large gaps in them. These would have been filled with air sacs that made the neck lighter and also helped deliver oxygen around the body. To hold up its bulk, Apatosaurus's legs were stout and robust, with the forelimbs being slightly shorter than the hind legs, and the femur being some of the most robust of any sauropod, considerably more so than Diplodocus. But also, it had comparatively long ribs, so despite its limbs being longer and stockier, it had a deep chest and a more stocky appearance. Apatosaurus had a single claw on the forelimb and 3 claws on the hind limbs. What they were used for isn't clear, as they face inwards and would have had been useless in defense, so scientists have suggested that they were used when females would dig up holes to lay their eggs, or for gripping tree trunks when they would rear up to topple a tree over. The tail is very long and ended in a thin whip-like structure that led many scientists to believe it could use its tail as a weapon, or even crack it to make a whip-like sound at high speeds. As awesome as that sounds, let's take a moment to think about it. Even if it could do so, the act of whipping its tail like that would probably break its tailbones or tear muscle apart, and if it had to use its tail for defense, it's likely it would have used the thicker base of its tail to batter away attackers. Another theory is that the movement of the tail was used as a form of communication, signaling to members of the herd and used to communicate without having to make verbal or more physically taxing signals. Sauropods are usually seen as slow and cumbersome animals, but trackways of Apatosaurus show that they could potentially reach speeds between 20 and 30 kilometers per hour, though not for very long. They may also have had to walk 25 to 40 kilometers a day in order to find enough food and water to fuel their giant bodies. Apatosaurus is the second most common sauropod in the Morrison Formation, with only Camarasaurus being more common. It also shared its environments with other huge sauropods like Diplodocus and Brachiosaurus. As discussed earlier, Apatosaurus and its close relative Diplodocus were low to mid-level browsers, while Camarasaurus and Brachiosaurus were high browsers. This is likely how so many enormous animals were able to live in the same area and not compete with each other, a good example of niche partitioning. All of these species would have been effectively immune to predators upon reaching their adult sizes. So, Apatosaurus. I see it as kind of a blueprint for the large, long sauropods, and is usually one of the first species thought of when we think of sauropods in general. And though it's not in the group's top 10 largest species, it is still an absolutely massive animal, the likes of which we can scarcely imagine. But what do you think of Apatosaurus? And for my weekly question, do you prefer the more horizontal sauropod species like Apatosaurus, or the more vertical species like Brachiosaurus? What lesser known species would you like me to do a breakdown on next? And until then, please like, share, subscribe, and thank you for watching.